Earthquakes. These sudden, powerful tremors shake our planet, often without warning. Imagine the ground beneath you suddenly rolling like ocean waves. Buildings sway, the earth rumbles, and fear grips those caught in the tremor's grasp. But what causes these dramatic events? Earthquakes are a natural phenomenon, a release of energy from deep within the Earth's crust. This energy travels outward in waves, causing the ground to shake and sometimes rupture. These waves can travel thousands of miles, impacting areas far from the earthquake's origin. Understanding earthquakes is crucial for several reasons. Firstly, it helps us comprehend the dynamic forces shaping our planet. Secondly, this knowledge is vital for developing safer building practices in earthquake-prone regions. Finally, knowing how to stay safe during an earthquake can be the difference between life and death. So, let's delve deeper into the fascinating and sometimes frightening world of earthquakes. To truly grasp the nature of earthquakes, we must journey beneath the Earth's surface. The Earth's outer layer, known as the lithosphere, isn't one solid piece. Instead, it's broken into massive, moving slabs called tectonic plates. Think of a jigsaw puzzle, but instead of stationary pieces, these plates are constantly shifting, albeit very slowly. Most earthquakes originate deep within the Earth's crust, along the boundaries of these tectonic plates. As these plates move and grind against each other, immense pressure builds up over time. Eventually, this pressure exceeds the strength of the rocks, causing a sudden rupture or slippage. This release of energy is what we experience as an earthquake. The movement of tectonic plates is the driving force behind most earthquakes. But what causes these enormous plates to shift and collide? The answer lies deep within the Earth's mantle, the layer beneath the crust. The Earth's core generates immense heat, creating convection currents within the mantle. These currents act like giant conveyor belts, dragging the tectonic plates along with them. The plates move slowly, typically a few centimeters per year, about the same rate as your fingernails grow. However, this seemingly insignificant movement has profound consequences over millions of years. It's responsible for the formation of mountains, volcanoes, and of course, earthquakes. Not all earthquakes are created equal. They vary in strength, depth, and the type of plate movement that causes them. Understanding these differences is essential for assessing earthquake hazards and designing appropriate safety measures. The most common type of earthquake occurs when two tectonic plates slide past each other horizontally. This is known as a strike-slip earthquake. The San Andreas Fault in California, infamous for its seismic activity, is an example of a strike-slip fault. Another type is a normal fault earthquake, where plates move apart, allowing one side to drop down relative to the other. Reverse fault earthquakes, on the other hand, occur when plates push together, forcing one side upward. Section 5. Measuring the power, the Richter scale. When an earthquake strikes, we often hear about its magnitude on the news. But what does this number actually signify? The Richter scale, developed by Charles Richter in 1935, provides a way to measure the energy released by an earthquake. The Richter scale is logarithmic, meaning that each whole number increase represents a 10-fold increase in wave amplitude and a 32-fold increase in energy released. For example, a magnitude 6 earthquake releases 32 times more energy than a magnitude 5 earthquake. Earthquakes below magnitude 2.5 are generally not felt by people, while those above magnitude 8 can cause catastrophic damage. The largest earthquake ever recorded was a magnitude 9.5 in Chile in 1960. Section 6. Shaking the world notable earthquakes in history. Throughout history, earthquakes have left an indelible mark on human civilization. These events, often accompanied by immense destruction and loss of life, serve as stark reminders of the powerful forces shaping our planet. One such event was the 1906 San Francisco earthquake, estimated at a magnitude of 7.8. The earthquake and subsequent fires devastated the city, claiming over 3,000 lives and destroying over 80% of San Francisco. Another devastating earthquake struck the Indian Ocean on December 26, 2004. This magnitude 9.1 earthquake triggered a series of tsunamis that ravaged coastlines across Southeast Asia, killing over 230,000 people. These are just two examples of the countless earthquakes that have shaped human history, reminding us of the importance of understanding and preparing for these natural disasters. Section 7. The aftermath impacts on people and the planet. The impact of earthquakes extends far beyond the initial tremors. They can trigger a cascade of secondary effects, leaving lasting consequences for both the environment and human life. One of the most immediate and visible impacts is structural damage. Buildings, bridges, and other infrastructure can collapse, leading to injuries, fatalities, and widespread disruption. Earthquakes can also trigger landslides, avalanches, and liquefaction, where the ground behaves like a liquid, further exacerbating damage. Moreover, earthquakes can disrupt essential services such as electricity, water supply, and communication networks. This disruption can hamper rescue efforts and pose significant challenges for recovery and rebuilding. Section 8. Tsunamis. The ocean's fury unleashed. While earthquakes themselves can be devastating, they can also trigger other natural disasters, most notably tsunamis. Tsunamis are a series of ocean waves caused by the displacement of a large volume of water, often due to an undersea earthquake. When an earthquake occurs on the ocean floor, it can cause the seafloor to uplift or subside, displacing the water column above. This displacement generates a series of waves that travel outward from the earthquake's epicenter. Tsunamis can travel across entire oceans at speeds of up to 500 miles per hour, reaching heights of over 100 feet as they approach the shore. The 2004 Indian Ocean tsunami, triggered by a magnitude 9.1 earthquake, tragically demonstrated the destructive power of these ocean waves. Section 9. Can we predict earthquakes? The ability to predict earthquakes accurately would be a game changer, allowing for timely evacuations and potentially saving countless lives. However, despite decades of research, earthquake prediction remains an elusive goal. Scientists can identify areas at high risk of earthquakes by studying fault lines, historical seismicity, and plate movements. While this information is crucial for long-term planning and hazard mitigation, it doesn't allow for precise predictions of when or where an earthquake will occur. Some researchers are exploring the use of precursor events, such as changes in groundwater levels or radon gas emissions, as potential earthquake predictors. However, these methods are still in their early stages and require further research and validation. Section 10. Staying safe when the earth trembles. Essential tips. While we can't prevent earthquakes, we can take steps to minimize their impact and protect ourselves during these events. Knowing what to do during an earthquake can mean the difference between life and death. If you're indoors during an earthquake, drop to the ground, take cover under a sturdy table or desk, and hold on until the shaking stops. Stay away from windows, mirrors, and heavy objects that could fall. If you're outdoors, move to an open area away from buildings, trees, and power lines. If you're driving, pull over to the side of the road and stop. Be prepared for aftershocks, which are smaller earthquakes that can follow the main shock. Section 11. Conclusion. Living with earthquakes. Earthquakes are a powerful reminder of the dynamic nature of our planet. While we can't control these forces, understanding their causes, effects, and safety precautions is crucial for mitigating their impact. By studying earthquakes, we gain valuable insights into the Earth's inner workings and the processes that have shaped our world over millions of years. This knowledge, combined with responsible building practices and public awareness campaigns, can help us coexist with these natural hazards. Remember, preparedness is key. By staying informed, having a plan, and knowing what to do during an earthquake, we can increase our chances of staying safe when the Earth trembles.